All right. Well, I hope everybody was able to look back through example one, kind of try it on your own, make sure you understand all the steps. Again, ask any questions. This is very confusing when you're first doing these. But again, the better that we get at doing these in chapter 8, the easier it's going to make chapter 9, chapter 10, and things as we go further and further. So definitely take a lot of time and effort to get these steps down because these are going to be the same steps that we're using throughout. All right, so let's take a look at example 2. So we've got a pre-test and a post-test were given to workshop attendees. The pre-test score average was 24, and the researchers want to know whether the post-test score is significantly different from the pre-test score. They sampled 50 tests and found that the sample mean was 24.8, assumed that the population standard deviation is 1.2, use a significance level of 0.01. All right, so again, just to identify some of the different pieces. So the pre-test score average was 24 and is significantly different is going to both go into our claim. So our 24 that we have is going to be related to our population mean. Our 50 is going to be our N, the number of people sampled. Our sample mean was 24.8. And then our population standard deviation is 1.2. And then notice with this one, they gave us the significance level of 0.01, so we actually know our alpha in this case as well. All right, so again, start off with step one. We want to make our claim. So with this one, since it's significantly different, this is going to be the equals not equals situation. So our H1 is going to be that mu is not equal to 24. Our H naught is going to be that mu equals 24. And so we've got our claim finished. So now we need to calculate our test statistic and our comparison statistic. So we need to calculate our Z sub t and our Z sub c for these. So if we look at our Z sub t first, we're going to take our sample mean minus our population mean, all divided by the standard deviation, divided by the square root of 50. So if we throw this in the calculator real quick, four divided by 1.2 divided by, whoops, to be divided by is square root of 50. And so it looks like we're going to get a Z test statistic of 4.71. All right, so now for our Z comparison, now since this one is an equals not equals, this is a two-tailed test, and so notice I've got the two separate sections shaded when it comes to this. So unlike the last one where we only had the one area, in that case that whole area was 5% because that was our alpha. So when we have a two-tailed test, this is more like our confidence interval where we're going to have to take our alpha divided by 2 to get the individual areas of these small sections. So in this case, we're going to get 0.005 for the upper blue, 0.005 for the lower blue, and then there's a 99% chance of being in the white. So with this one, we do want to actually calculate both the positive and the negative Z sub c's because we don't necessarily know which one we're going to be using until like we've finished our way. We kind of do in this case because our Z of t is positive, so we know we're going to be up in the upper end. But if we calculated our comparison first, we wouldn't necessarily know right away. So just like before, so if we're in the blue, this is going to be where we can reject H naught. So in this case, we can either reject H naught on the high side or the low side. And if we're in the white, that's going to be where we fail to reject H naught for these. All right, so now that we've got our percentage that we need to throw into our calculator, we can go ahead and calculate our comparison Z. So we're going to do inverse norm of 0.005, comma 0, comma 1. Whoops. And if I throw this in the calculator real quick, it looks like we're going to get negative 2.58 for this guy. So that means we're going to have negative 2.5 here, and then positive 2.58 there. So now we want to see, where does this 4.71 fall in relationship to these z comparison scores? So does it fall in the white, or does it fall in one of the blue regions? And so 4.71, if we were to graph it, it's probably going to be way up here on the right. So it definitely falls into this upper blue region. So based on the test statistic, it looks like we're going to reject H naught for this one. All right, so now let's calculate our p-value and verify that this really is less than our alpha of 0.01. So to calculate our p-value, we're going to do our normal CDF of our 4.71. So in this case, so I'm thinking about it, since it's on the upper side, I want to calculate this as the lower bound. If it were in the blue on the bottom, then I would calculate this as its upper bound. But since our 4.71 is on the high side, I want to set this as our lower bound, and then some ridiculously big number, and then 0, comma 1. And since this is a two-tailed test, we're going to multiply this answer by 2. So when we're finished, we're just going to multiply this whole thing by 2. All right, so throw this in the calculator and see what we get. So I'm going to do normal CDF, 4.71, comma, some ridiculously big number, comma 0, comma 1. And then that's already small as it is, so this looks good, but now let's go ahead and multiply by 2. And so now we've got 2.48 e to the negative 6. So our p is going to be 2.48 times 10 to the negative 6, which at this point, if you know anything about scientific notation, we know this is definitely less than our alpha of 0.01, but if you just want to write it out, so it should look like that, which is definitely smaller than 0.01. So our p-value supports our test statistic up above. In both cases, we were able to reject H naught. So finally, our conclusion is we reject H naught. So there's sufficient evidence to support the claim that there is a difference between pre and post-test NRT scores. All right, perfect. This looks good, everybody. So with this section, I've got tons of practice problems. I would definitely recommend doing as many of these as you can, just because the more practice you can get, the better. Definitely play around with some different varieties of differs, less than, greater thans, things like that. So with these, I only have, I think, 6 total maybe. So what I might do is double up and have a couple different groups working on the same problem so that they can get posted to the collaboration space. But I would definitely encourage you to do as many of these as you can, because the more practice we can get, the better we'll be. And so there's no homework yet. So like in this section, like there is a homework chapter, but doing these practice problems, I'm going to count as the homework because I've got so many of these different practice problems that's going to count in place of an actual homework set. So go ahead, practice these. Message me if you get stuck. If there's anything you need me to write out, or if you want me to check how you're doing, please let me know. Like I said, this is some tough stuff. We're really getting into the heart and soul of what is statistics. And so the better that we can get this stuff down, the stronger we're going to be later on. So again, don't hesitate to reach out if you have any questions. So good luck and awesome job, everybody.